All right, well, welcome back. We're going to be talking about a couple of topics today, and that is strong versus weak entities. Very interesting topic, and it's a kind of a strategy on how to build effective logical data models. And then we're also going to talk about resolving many-to-many relationships. We've talked about one-to-many and one-to-one relationships. Our next step is to figure out how to resolve those many-to-many relationships, which is typically a little bit more involved, but it can also uncover some information that we may have missed earlier in building an ERD. We're making good progress this semester, and I'm hoping that these videos are helping you understand the material better. I'm enjoying creating them for you, and I'm hoping that you're finding them useful. I would be interested in any feedback that you want to give me, because I'm hoping to use these in the future, and I certainly want to make them effective for you as possible. Having said that, the last two videos that we watched, or that you watched, video 2 had to do with logical data models. I hope you're finding that to be a very useful coverage of the material, because logical data models are going to be one of the most important topics we're going to talk about this semester, at least with regards to modeling. And then video 2A, our quote bonus video, so to speak, was to help you understand how to draw logical data models in Visio. And I also covered the power of foreign keys, so that you understood how foreign keys worked a little bit within Access. We're not going to be using Access much this semester, but it can be a useful little test bed to try out things so that you can see how they work. So I'm hoping these videos are working well for you. Please do let me know and give me any feedback that you might have on how they're going. Today's agenda, we're going to cover two fairly challenging topics, and that is what is a weak entity? And then we're also going to talk about how do you resolve many-to-many relationships with ERDs. We've talked about one-to-many relationships, resolving those, as well as one-to-one relationships. Many-to-many relationships are a little bit more complicated, and so I thought we'd do a dedicated video on that topic alone. So let's start off our conversation about weak entities let's talk a little bit about what is a weak entity. A weak entity is conceptually, an entity that depends on another entity. And that in and of itself I know is pretty vague, but hopefully that will make more sense here in just a minute. So a weak entity is an entity that can't stand by itself, but it's an entity that actually relies on another entity for its existence. And weak entities can be actually very powerful ways to model entities, especially when there is that dependence. So let's take a situation where we've got an entity called building. I'm going to try out my pen here, and I'm going to use that. And we've got another entity here called room. Now, not surprisingly, building can have many rooms, and we might say that building has to have a room. And a room, of course, can be in only one building. It's kind of hard to have a room in multiple buildings, I think. So this is pretty straightforward. And we might have here like a building ID as the primary key, and I'm going to use an asterisk to indicate that. And then we also might have the building name. I think these are all pretty straightforward. Well, what about room? What's the primary key for room? Well, we could do, I suppose, a room ID. But let's think about that just for a minute. Room ID could be, fine if we're only dealing with one particular building. But what about if you're the University of Delaware? We might have 100 buildings on campus. And so is every room on campus going to have a unique identifier? I suppose we could use that approach, but again, that's going to get pretty challenging to keep track of all those rooms. So I'm going to erase here room ID, and I'm going to think of another strategy. So instead of having a unique identifier for every single room on campus, to be thousands of them, I'm going to take advantage of our one-to-many relationship here. And you'll notice, of course, that if we use our heuristic of one-to-many relationships, we're going to take the primary key on the one side, which of course is building ID, and it's going to become a foreign key on the many side. So we're going to use building ID, and that's going to become a foreign key. Now here's the question for you. With building ID, could we couple building ID with another column and make a unique identifier. So instead of having just a single column that is a room number as the identifier, maybe we could couple it, well, let's say maybe, how about room number? Now each building might have, or many buildings might have the same room number. There might be a lot of 101s, for example. But if we think about it, this room number combined with this number are going to be unique. And that is that the combination of building number and room number will uniquely identify a room on campus. So that's a strategy called a weak entity strategy, and we notate that with a little W up here, and that indicates that room is a weak entity, which makes sense. I mean, if you think about it, a room is dependent on the building. I mean, if we destroy the building, we destroy the room. And so this allows us to model that relationship. And so a broader definition of a weak entity here, this concept right here, is an entity not only that depends on another entity, but it's any entity that has, as part of its primary key, a foreign key. So any entity that has, as part of its primary key, a foreign key, by definition, is dependent on another entity. So in this situation, room is dependent on building. Now let's take other situations here. I'm going to go ahead and use my eraser here. That's kind of cool. Alright. Good. Let's try that. Now let's try something else. What about, it's kind of a dated concept here, but what about a compact disc and a song? Again, you might think, well, you know, of course a CD can have many songs. A song can be in only, with regards to the CD, can only be on one CD. Now I know this is not MPEGs, this is a song that's on a CD. And that song is actually contained inside that CD. So we might have, for example, a CD number that we come up with. It might be a number we stick on there on the case and use that. And that's going to be the primary key for CD. Well, again, if we want to use a weak entity strategy here versus a strong entity, with a strong entity, every single song in our CD collection would have a unique identifier. Song 1, Song 2, Song 3, Song 4, Song 756. But with a weak entity strategy, we could do things a little bit differently. We could use now, take the primary key on the one side, which is going to, of course, be CD number, and we're going to actually use that CD number, erase that so it doesn't look too confusing, here. That's going to be a foreign key. And then we could couple that with what? Well, how about track number? The track number on the song now, coupled with the CD number, uniquely identifies the song. And this really illustrates well the strategy with a weak entity. One of the advantages of a weak entity strategy. The key here between the combination of CD number and track number is much more meaningful than coming up with an arbitrary number to assign every single song in our collection. Similarly, being able to say that you're going to building number 42, let's say that's Purnell Hall, room 012, which is my office. This is much more meaningful than coming up with an arbitrary number for every single building or every single room on campus. So weak entity strategies in certain situations can be much more meaningful because they actually provide more insight into the entries into the dependent entity. In this case, is song. Okay, so our other topic today is many-to-many relationships. So let's take a situation where, you'll notice I'm really getting into using this pen, so hopefully this has been valuable to you. So let's take a situation where we have a many-to-many relationship. We have doctor and patient, and we're going to actually put the name here. I don't do that enough. And we're going to say a doctor treats a patient. So a doctor certainly does not have to treat a patient. We have some research doctors who don't ever treat patients. And a patient might never actually see a doctor. They might just see a nurse or something like that. So this is a many-to-many relationship. And you'll see many-to-many relationships abbreviated either N to M, or sometimes you'll see them also N to N relationships. And this indicates a many-to-many relationship. So on both sides here, really they are two one-to-many relationships is what you can think about it. A doctor treats zero-to-many patients here, and a patient going this way will actually be treated by zero-to-many doctors. So the problem with this is that, and one of the reasons we start out in Visio with not using the LDM, the logical data model template at the beginning of the year, is that Visio will not implement and will not allow you to diagram in its using its database template many-to-many relationships. And there's a good reason for that, and that is that many-to-many relationships cannot be implemented on a relational database. They cannot be implemented. There has to be a way to resolve them before you actually implement them. So that's why we have to kind of treat them as a special case. What usually happens with many-to-many relationships is you're missing something, and you're missing something in space and time very often. In other words, there's something going on when these two interact that has a different dimension, additional dimension. In other words, doctors and patients see each other, and it has something to do with either space, that is a location in somewhere, or time, and that is that they see each other or interact with each other multiple times. So when we have many-to-many relationships, there's something going on in between here, okay, in between this relationship that we have to deal with. Now, from an ERD perspective, many-to-many relationships are fine. We actually encourage them. But when we get to the logical data model, which is a little bit more specific and closer actually to the implementation, we want to resolve it. We want to resolve that situation so that we can provide some insight. So this is the ERD version of this. I'm going to erase this now so that you can see and we can actually resolve this. Now, if you remember, we had actually, I'm going to draw this up here so that you can see it. You can remember we had a many-to-many relationship. So don't forget that, because that's going to be important to remember later on. The question is how do doctors and patients interact or intersect with each other? And to resolve a many-to-many relationship, we have to come up with that intersection. That is, how do they interact in time and space? How do they actually impact each other or interact with each other? And one approach might be to say that they interact in an appointment. Maybe what we're actually trying to keep track of is an appointment. And again, in that spirit of space and time, that makes perfect sense because, with space and time, doctors and patients interact in an appointment. So what we end up with is an intersection table between these two. And the rule of thumb is, by the way, with an intersection table is that they're pretty easy to figure out because these will always, always, always be required. So the minimum and maximum cardinalities on the original entities here, that is both patient and doctor, these minimum cardinalities are always, 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 always going to be 1-to-1. Mandatory ones. That's pretty easy. But now the question is going to be, well, so what are the cardinalities around appointment? Well, there's a good rule of thumb for that as well. And I'm going to talk about in class what I call the hip-hop rule. And I know you're going to laugh, but it works pretty well. And you're going to see that the cardinalities come from the original relationship, but they kind of go backwards. So in this case, we actually have 0 to manys on both sides, so it's pretty easy. And that's how it works out, just like that. Now, if we had, this is kind of still an ERD approach because we don't have any attributes, but let's assume that our primary key here for doctor was, let's say, a doctor ID to keep it simple, okay? And then here, this is a patient ID, the primary key. I'm not actually drawing it inside the box, although I probably should be. If we go back to our rule with regards to one-to-many relationships, it's pretty straightforward. We have two one-to-many relationships. So the primary key on the one side, here and here, become the foreign key on the many side. So we end up with doctor ID as a foreign key. Okay, oops, I'm tipping my hand here. We don't want to quite get there yet. And then patient ID is also going to be a foreign key. And then the question we want to ask ourselves, is this combination together unique? Is the combination of a doctor and a patient number, is that going to be unique to identify a specific appointment? And the answer to that question, your first answer might be, well, yes. But if you think about it, it's actually no. That combination is not unique because I go see the same doctor all the time. I might see my doctor each year for a physical or for an appointment. And so in that situation, the combination of doctor and patient is not going to be unique. And so what we really have to face is the addition of additional columns to identify the appointment. And of course the most logical ones would be the date and time of the appointment. Alright, so I'm going to take out that no now because we actually do have that yes. How about that? Now the assumption is that a doctor can see a patient only one time on a particular date and time. And I think that's a reasonable assumption. An appointment is uniquely identified for a specific doctor and a specific patient at a specific date and a specific time. Now, for those of you who are kind of ahead of the game, you might say, hey, wait a minute. This is a weak entity. And you're right. Because remember, we identified weak entity as being an entity that has, as part of its primary key, a foreign key. And all intersection tables, when you resolve a many-to-many relationship, will be weak entities. So this is actually a weak entity. So let me try one more here, and then it's going to be a little bit more involved. Let's do book and author. Okay, so we have book and we have author. And let's assume now that a book has to have an author. So it certainly could have many authors. And the author could have 0 to many books. All right, now that's where we're going to start. So this is the ERD approach. The ERD approach. Now, once we get that at the ERD level, at some point, of course, we're going to have to resolve it. So let me erase this. And let's now get to the LDM. The LDM, of course, we're going to have an intersection table. Now, sometimes you end up with something kind of cool. Author, or appointment rather. That was kind of a nice little brainstorm. It was something that we know and can identify. Unfortunately here, sometimes you just end up with a combination of the list of books and their authors, or contrastly, you could say a list of the authors and their books. And so the convention is really just to name it author hyphen book, to indicate that this is going to be the intersection of that. Okay? And so when we draw our lines for the intersection, and as I told you before, these are always going to be mandatory. That's easy. And if you remember now, the relationship that we had before we started between book and author, this was optional and this was mandatory. And so using the hip-hop rule that we're going to talk about in class, this will go here and this will go here. And so what we'll end up with is a 0 to many here and a 1 to many here. Okay? That's how the hip-hop rule goes, and you'll understand why I call it that in class once we talk about it. So now, given that, what we end up with is, if we have, for example, book might be ISBN as the primary key, author might be the author ID. And these are both primary keys. Resolving it now so that we have an LDM, logical data model, what we end up with is the primary key on the one side, ISBN, is going to become a foreign key on the many side, ISBN, and that's going to be a foreign key. And again, the primary key on the one side, author ID, is going to become a foreign key on the many side, which is author ID. Now the question then becomes, does the combination of these two, is it unique? Well, and it probably is, if you think about it. I mean, an author cannot write a same book twice. And a certain book cannot have the same person as an author multiple times. So in this situation, that combination will work fine. So this is an example of how we resolve many-to-many relationships. We're going to go through a lot more of these in class, so hopefully you get an understanding of how they work. All right, I have an exercise for you to do, not surprisingly, given that the E part of the exercise of the ropes framework is exercise. So here we have two binary relationships. We have entities here. We have employee and we have dependent. Now what I'd like you to do for this is I'd like you to focus on weak entities. And I want you to think about, okay, we have an employee that works in our organization, and that employee has dependents, for tax purposes, typically their children. I want you to think about what are the trade-offs between using a strong versus a weak entity approach. And how would that look? If we were going to model that from a logical data model perspective, how would that look? How would it look from a strong entity perspective for dependent versus a weak entity perspective for dependent. So that's your first exercise. The second exercise is I want you to focus on a relationship that you frequently see in entity relationship models, and that is order and product. An order must have at least one product on it. Of course, it can have many products. And going the other direction, a product doesn't have to appear on the order. I mean, when we first introduce a product, it might not appear at all until we finally sell it. So a product could be on 0, but it certainly could be on many orders. Now, I think you can anticipate what I'm asking you to do, and that is I'd like you to look at the intersection. What is going on between here, and what is this between here? The other question I'd like you to think about is, once you find the intersection table and you give it a name, I want you to ask yourself, what other attributes could it have? Clearly it's going to have a foreign key, presumably an order ID and a product ID, but what other entities or what other attributes could it have in addition to order ID and product ID? What is something that you might want to add to that entity that reflects the fact that it is the intersection between order and product? So the video today, we covered two very important topics. One was weak entities, the idea that a weak entity can be actually dependent on another entity, and we define weak entities as being an entity that had as part of its primary key a field that was a foreign key to another table. So that's what we defined as a weak entity. We also talked about the many-to-many relationship, a little bit more challenging to resolve than a one-to-many or a one-to-one relationship. But it also, as you could see, helps us uncover information that we might have missed. So getting some experience in resolving many-to-many relationships is very important, because you will definitely face them when you're constructing your own databases. I hope this was helpful, and I certainly, if you have any questions or need any additional assistance, please do come and see me. Take care, and I'll see you in class.